All right, this lesson is lesson 6 from unit 4 from Wednesday, December 2nd, solving systems of linear equations algebraically using the substitution method, second day of doing this. All right, so we have two equations and we're going to solve the system graphically first. In order to graph a linear equation, it has to be in y equals mx plus b form. So this first one is in y equals mx plus b form because the y is by itself. So the line y equals 3, you're going to go, so here I'll write y equals mx plus b. So in this case, we just have an y-intercept of 3. There is no slope. So y equals 3. We're going to go to 3 on the y-axis. And what this means is that no matter what, the y value of every coordinate is going to be 3. So it's going to be a horizontal line going through 3 on the y-axis, right? Because we have the point 2, 3, 3, 3, 4, 3, 5, 3, negative 5, 3. The y value is always 3 and has a slope of 0. The second equation is not in y equals mx plus b form. So I'll just write here that the b is 3. So for this one, we need to get the y by itself. So to do that, we're going to minus 7 on both sides, and then we'll rewrite our equation with the y all by itself. Y equals 2x minus 7. You cannot combine the negative 7 with the 2x. One has an x and one doesn't. They're unlike terms. So now this is in y equals mx plus b form. So this was our first linear equation. This is our second linear equation. And now we can go ahead and graph that second linear equation. All right. So for this one, our slope is 2, right, as a fraction. So 2 over 1. We're going to be going up 2, right 1. And our y-intercept is negative 7. And for this one, just to go back real quick, I wrote down that the b was 3, and our slope is 0, which comes from that 0x. If we want to rewrite this equation, y equals 0x plus 3. That's how we get the y equals 3, because 0 times anything is just 0. All right, so our slope was 0 for this one, and our b was 3. Now for this line, we have a b of negative 7. And we're going to move up to right 1. All right, as soon as it hits, circle it. Go down to left 1 to make some more room. And now we have our system graphed. System, again, is just two linear equations. I'm just going to label this one with the original. So y plus 7 equals 2x. And then y equals 3. Okay, and our point of intersection is the point 5, 3. Because remember, our points go x, y. So this is our point of intersection. Okay, now that we solved that system graphically, we want to look at how we can solve this system algebraically. That's the new information here. So I'm going to rewrite our two equations, y equals 3 and y plus 7 equals 2x. So if you look here, we know the y already. We know that y is 3. We know the y is 3. So we can take this 3 and we can plug it in for this y right here. Because y is 3, so we can plug that in. And now we just have one variable so we can solve. When you have an equation with an x and a y, you can't solve it. We don't know. There's two unknown things. But now we just have the one unknown thing, the x, so we can solve that. Okay, so we plugged in our 3 for y, and now we can go ahead and solve. So 3 plus 7 is 10. We can divide both sides by 2. And we know that 5 is x, or x is 5, if you write it the other way around. All right, so now let's look at our solution. So the ones we were doing yesterday, or whenever you're watching this, the lesson before, you would then take this value for x and plug it back into one of the originals. which you can go ahead and plug it back in for one of the originals. There is no x in the first original, but you could plug in that 5 for this original, and then 5 times 2 is 10, and then 10 minus 7, and you're going to end up with y equaling 3. But you don't have to do that because for this one, we know the y. It says at the beginning, y is 3, y equals 3. So our solution is x comma y. So in this case, we know our x is 5 because we figured that out, and our y was 3 because we knew that one already. So this is our solution. All right, let's keep going. Let's go over the steps that we just did. Solving algebraically with the substitution method. You're going to find the equation that has a variable completely by itself on one side of the equal sign. Okay, so you're going to look for the one that has the variable completely by itself. You're going to take that number. So in that last example, it was y equals 3. You're going to take that 3, and you're going to plug it in wherever you see a y in the other equation. Okay, so substitute the number in for the variable in the second equation. Then you're going to solve for x or y, whichever variable you have left. Write your solution, and then we can also go over how to check them. All right, so we have y equals -4, and then we have y plus 10 equals 3x. So we're given that the y is -4. So we can take that -4 and plug it in for y. So instead of y plus 10, we have -4 plus 10 equals 3x. Okay, and now we can solve for x. -4 plus 10, let's simplify this side. That's going to be 6. 6 equals 3x. Divide both sides by 3, and you get x equals 2, or 2 equals x, same thing. Okay, now that we know that, we can write our solution. Solutions go x comma y, so let's just move down. All right, so I'll just write that here, x comma y. So our x is 2, we just figured that out. And our y they gave us at the beginning was -4 in that first equation. So our solution is 2 comma -4. Okay, let me show you how you could check this. To check it, that point, 2 comma -4, has to be on both lines. So our first one is just y equals -4. So let's see, if we plug in -4 for y, -4 equals -4. So that one checks. Let's write our second equation, which was y plus 10 equals 3x. Let's plug in the -4 for y. And let's plug in the 2 for x. -4 plus 10 is 6, and 3 times 2 is 6. So that equation checks as well. So again, to check, you take your solution, the x and the y values, and you plug them into both equations. Wherever you see an x and a y, you plug in those numbers, and it should balance and check out. That means that this point is indeed on both of those lines. Okay, let's solve this one algebraically now. So they're telling us that x is 5 is one of our equations. So if we know that x is 5, we can take that 5 and we can plug it in for x. So then we're going to have y minus 8 equals 2. Instead of 2x, it would be 2 times 5. Okay, now let's solve for y. So in this case, we're finding y. We're given x and we're finding y. All right, so let's simplify this side. 2 times 5 is 10. Add 8 to both sides. And we get y equals 18. All right, so let's remember how to write our solutions. Every solution goes x comma y. So we just figured out that the y was 18. And the x they gave us at the beginning in the first equation, x was 5. So our solution is 5 comma 18. All right, check it. To check it, we rewrite both equations. So x equals 5 and y minus 8 equals 2x. And then let's plug in our solution. So we think that the x is 5 and the y value is 18. So let's plug in a 5 wherever we see an x. And let's plug in an 18 wherever we see a y. And let's see if they check. Well, 5 equals 5, that one checks. 18 minus 8, let's see, 18 minus 8 is 10. 2 times 5 is 10, so that equation checks as well. So the point 518 is on both of those lines. All right, moving right along. Okay, for number 3, they give us 2 lines again, right? A system, 2 lines. We have y equals 2. And 3x plus y equals negative 10. So we know that what the y value we're giving us is 2. So again, that's going to be that horizontal line where the y is always 2. So let's take that 2 and plug it in for y. So 3x plus whatever y is equals negative 10. Well, y equals 2. Now we can solve for x. Minus 2 on both sides. 3x equals negative 12. Divide by 3 on both sides. X equals negative 4. Okay, now let's write our solution. Every solution goes x comma y. We just found out our x is negative 4, and we know from the beginning our y is 2. So our solution is negative 4 comma 2. All right, let's check it. Rewrite both originals. Let's plug in our negative 4 wherever we see an x, and a 2 wherever we see a y, and see if it checks. Well, 2 does equal 2, so that one works. And then over here, 3 times negative 4 is negative 12. Negative 12 plus 2 is negative 10. So this one checks as well. All right, number 4, they give us x equals negative 5. So let's take that negative 5 and plug it in for x. And then we will solve for y. So we're going to plug in our negative 5. Let's simplify. 2 times negative 5 is negative 10. Bring down your plus 8y. Now we have a 2-step equation. To get rid of a negative 10, we're going to add 10 to both sides. This will cancel and make 0. Then you're left with 8y equals 24. Let's divide both sides by 8. And you get y equals 3. All right, so for our solution, we just found out that our y was 3. And we know from the beginning that our x value was negative 5. Okay, I'm not going to check this one, but just know that you would rewrite both originals, plug in negative 5 for x, 3 for y, and make sure that it balances just like we did in this one. All right, for number 5, y equals 7. So that means I can plug in that 7 for y. So we have 2x plus 7 equals 19. Right, now we can solve for x. Let's minus 7 on both sides. 19 minus 7 is 12. And then let's divide by 2 on both sides, and we get x equals 6. Our solution goes x comma y. We just found out that our x was 6, and we know our y is 7. All right, and number 6, we're given x equals negative 4. So let's take that negative 4, plug it in for x in the other equation, in the second equation. So then we're left with 5 times whatever x is, plus 2y equals 0. Let's plug in negative 4 for x. Now let's solve for y. Let's simplify this first. 5 times negative 4 is negative 20, plus 2y equals 0. We're trying to get the y by itself, so let's first get rid of this negative 20 by adding 20 on both sides. That will cancel, so we're just left with 2y equals 20. 0 plus 20 is 20. Now we need to get rid of this times 2, so the opposite would be divide by 2. Do it to both sides, and you get y equals 10. Okay, so our solution goes x comma y. Our x we got from the beginning. The first equation told us x was negative 4 always, and our y value is 10. And I will check this one. So to check it, we're going to rewrite both originals. Okay, yeah, this is our last one. So we'll just check this one as our last one. So x equals negative 4. and then 5x plus 2y equals 0. All right, so wherever you see an x, let's plug in -4. -4 does equal -4, so that one checks out. Let's plug in -4 for x in the second equation and 10 for y in the second equation. 5 times -4 is -20. 2 times 10 is 20. -20 plus 20 is 0. So 0 does equal 0, and it checks. All right, so this was the second day of substitution. Thanks for watching.